Well, good afternoon, everyone. My name is Thiago, as he said, and I've shortened the bio because it was actually huge. So, um, and act, and by the way, I'm here representing my company, which is from Brazil. It is CPQD, and also representing Embrapi, which is the foundation that's given us the opportunity and also funding for us to do our whole work here. And I'm going to talk about a little bit about CPQD and our campus, but I'm not going to extend them very much because I don't want to bother you guys with, pitch for my company and that sort of stuff. So I'm gonna be very fast and very quick because I have a very short time. So, by the way, not going to read all of that, but we are located in São Paulo, Brazil, Campinas, the headquarters. We have 900 collaborators, almost like that. And we have lots of patents. We have, we are a research institution, which is, by the way, funded by the Brazilian government. And we do have a lot of other products, but we are not a pro-profit organization. So, and there are a lot of projects going on at the same time. I'm going to talk about only one of them, okay, which is a huge one, by the way. And this funding is upwards of tens of millions of dollars going on into the Open RAN. And there are other projects with running Open RAN also. The team is large. That's why I'm not focusing on myself here, because there's a very big team working in Brazil regarding that, because the telcos themselves, in Brazil especially, they actually don't want any kind of lock-in. I work in the industry for quite a while with the telcos, and they kind of complain that they do have a lot of, companies that sell them the silo and they want to move away from it. But telcos are not known for particularly having state-of-the-art technology. They are very conservative. So by being conservative, they don't tend to adopt newer technologies, but they're very, very interested in Open RAN. We have worked with another telco companies, but only in the lab and not in this specific project, because we do have a lot of them. So this is a quick introduction. So also, we don't work only with mobile networks. We work with embedded electronics, security, advanced computing. Myself, I work with virtualization. I came from a background from networks, and we have a lot of whole team dedicated for the mobile part. I'm here representing all of them. Okay, we have a security team, IT team, so they're pretty big. So, going more laser focused on the topic here, just jumping from the boring part. We work with the Open RAN, which is an initiative, Open RAN Brazil. We have that project going on for, I think it's 1 or 2 years already. It's in partnership with RNP. And also we do have a 5G initiative, which it's the development of an end-to-end 5G initiative of our own, okay? So we work with multiple vendors providing 5G core and multiple RUs, for example, Benetel and that sort of vendors. But what I'm focusing today, and this project that's over there started this year, middle of this year, right around April this year, It has five major topics. The major one is the R&D, which only this part is the actual project that focuses on research. So we have already upwards of 10 published articles on 5G ecosystem, which includes AI. There's a sole project to AI, Auto RAN, which is my project, which handles getting all the components to the cloud. So cloudification is our word here. We intend to grab every component and get into the cloud. That's including every component that we can. There are other projects that focus, for example, on RAN, srsRAN, that focuses more on the RU side. And there are a lot of others. So that's just one branch. And for each project, there are at least 10 people working on it. We have a branch for training and education because we want to spread the knowledge throughout Brazil with that funding. So it's not just about, developing and researching. We also want to spread the knowledge and get people with qualification to work with 5G in Brazil. Also, we have major partnerships with major institutions like federal institutions. Also, we're attracting startups, and we have a test bed. And we already have one, but we're expanding it to do all of those testing that we need. It's pretty big. We have, like I said, many vendors. Foxconn is one of them, Benetel. There are a lot of them. Don't know if I can say all of them, but because we have NDA with some of them. But they're kind of a mix. Okay? So going to the topic. So I'm going to the Auto RAN, which is my project, which focus on getting the components into the cloud. So that's our main focus. Okay? So why? Why we want to do that? Well, first of all, we can leverage the power of the cloud, like for performance, let's say. How? For performance, let's say that, we generally, when we work with local servers, we can place the servers right on the edge. But what if I could place the CU, for example, in the cloud? That could leverage not only cost, because, well, whenever I can scale up or scale down, or perhaps even place the CU near the edge when it's needed. So whenever the CU UP is like full of it needs more processing power and can increase it, or perhaps I can give it high availability by providing multiple locations for them to run in. So I can decrease latency, for example, by placing the CU near the edge. So there are a lot of things that I can do. But it's a big problem because by doing this, I kind of complicate things. Because, first of all, each cloud, like AWS, Google Cloud, Oracle even, each one of them has its own API. It doesn't have a standard on its own. So we're working on developing in a plugin that kind of get all of these clouds and creates a generic API that follows, the ETSI standards. So we're looking to building that right now. It's not finished because, like I said, it's an ongoing process. It started this year. Also, on top of that, we are looking for scalable network functions. What's that? Well, we want, as I said, I want to scale and place as many functions as I can, or perhaps place it near or far, and has perhaps the AI decides, like with an intent. Like I have an orchestrator that has an intent, like, well, I want a latency to my customer that's no bigger than, let's say, 10 milliseconds. And the system must adhere to that by trying to understand how the network, how the system works, and try to accomplish that by making more instances or optimizing the placement of each component, okay? So that's the idea. It's not done yet, okay? And we're working, as I said, with different vendors to do that. So let's go a little bit in the specifics of what we have done so far. So what I have done, as you can see here, we don't have the RIC component. We're working on that, but we did place the 5G core and SMO on AWS. We have an orchestrator, okay? And this orchestrator uses the O2 to actually initiate and instantiate the core or SMO whenever it's needed. So I can place it on an AWS in let's say in São Paulo, Brazil, or I can place it in Virginia whenever I need it. So that's the point. And we want to place in the future all of them to work with Kubernetes, right? And you can see something really peculiar here. I placed a node 201 here on srsRAN. This interface does not exist, right? We did a little thing here. It's not much. Actually, we have a container here that translates the commands from the SMO, which comes from netconf and Yang, and translates into configuration for srsRAN and restarts it. Okay, so we've done that. It's not wow, but it makes possible for us to test the environment of SMO along with srsRAN. Okay, so we test that, and we have a demo for it. So more on the environment. This is a VPN. We closed the VPN from our edge cloud, which is based on São Paulo, Brazil, and also on an AWS. Okay. So what we're going to see now is a demonstration of we orchestrating the SMO and actually trying to run an UE locally on the edge. Okay, let's see if the video works. Oh, okay. By the way, this is the diagram. I think it's a little complicated. It's too much information. Okay, but over here we have our local setup. We did set up the VPN like this. So we have a couple of site-to-site VPNs here in private gateway. This is the N6, which the core uses to access the internet. So the internet actually, it's not coming from here, but it goes all the way to the AWS and gets the internet connection from here and goes back all the way to the client, to the UE. Okay? So there you go. Let's see if it works. Okay, it works. So let me have, oh, by the way, this is the login for our orchestrator. Okay, so this demonstrate we logging in, and these are the clusters. So we have a couple of clusters set up already. Okay, we have our services that we create, and these are services like the SMO, and the SMO. It was quick, but it pressed the button to stop. So the Kubernetes is going to stop all the Kubernetes instances running on that cluster. Okay, so the whole server is going down. Okay, just to demonstrate that it really is doing what it's supposed to be doing, which is removing the Helm chart from that cluster. And in the future, we're going to include the possibility of not only, because today we manually insert those clusters, okay? But in the future, we plan to integrate with AWS and Google Cloud so we can have a better experience. So just to show that the SMO is not working because we did just turn it off because it's terminated, right? So let's go a bit further, just not to waste anybody's time. Oh, by the way, this is the actual output from our, as I said, we have an O1, we have a little container that's running and actually detecting if there's any netconf or YUNG command coming from the SMO. If there's none, it doesn't do anything. So it's just running on the background there. Oh. Okay, just pressed the wrong button here. Just went too far, I guess. Yeah, sorry about that. There you go. So, let's go a little bit further here. Okay, jumped a little bit too far. But we did a little test here with a speed test just to show that the environment is working. So SMO is still off. We did a little test. It's not much because our link actually is not that big. The link between our servers and AWS is at most 200 megabits per second. So it's not much. So don't expect too much throughput there. So let's go forward a little bit. So here we're showing the configuration, okay? And as you can see, it shows there. Let me see. Oh, okay. It will just turn off SMO. It will instantiate. There you go. You start running all the components. Okay. Okay. The system also shows the actual pods that are running inside each cluster on the GUI. So let's go. Go a little bit further. Okay, so there you go. The system is up. And now we have to insert a new element. Oh, that, by the way, switch to English. So we are inserting the ORAN there. So that's the srsRAN. And that's the IP address for it. It's a local one. Remember, this is a VPN, so we're using only private network. This is the username and password for it. Just go ahead. And there you go. Elements are registered. As you can see, it's connected. And yeah, so it's connected. And we are going to try to, well, we configured the E2 interface. And then we will try to change something now. We're going to change the PCI for it. So we're going to do that. We're going to 471 to 470. Oh, just showing that's 571. And then we're going to change it to another value. And there you go, it just changed the value on the file. Like I said, it's just a container that changed it translates from netconf to the configuration YAML from srsRAN. And it just did change. And we'll connect. I'll just jump ahead.
So when you make that change, a script that is restarting?
Yeah, exactly.
Okay.
It just restarts.
You haven't had any issues with COTS phones not picking back up the network?
Sorry?
You haven't had issues with the phones not re-registering correctly?
Well, not so far. Not much, although, really. Actually, it takes a long time to register. We noticed that, but it does. Yeah. But it takes a long time. That's an S23 Ultra. It's a real UE, but it takes a long time. That's could be one of the issues, but it does take a long time to register. It has that. I don't know if there should be any issues there.
It's not on the GNW side. It's a problem with the phones.
Oh, okay. But there you go, and it works. Afterwards, we try to change the MCS also, just to show that it's doing what it's supposed to be doing. And I think we increase it, so it increases the bandwidth. And that's it. And also, it's all working on AWS. Our work is to grab all those components and put them into the cloud. So we're trying to do that as quickly as possible. So it's not easy because, as a lot of other presentations here said, there are a lot of hardware components that are needed for many, like CUs or DUs, like CPU pinning or specific hardware like NICs from Intel. They require specific hardware. So we're kind of trying to, from some vendors, to remove that lock-in. Not from srsRAN, obviously. That's why we have another slide just to demonstrate. This is not srsRAN, but just to demonstrate another work that we're doing. This is the orchestrator, and these are components from vendors, all right? But these ones we're trying to port up into the cloud also. And they are bound to the hardware themselves. And we're trying bit by bit to remove those dependencies like the PDK or, no, the PDK is kind of not the issue, but the hardware itself. But we're trying to remove it and move into the cloud. But what we are demonstrating here will be the UE connecting and the E2 actually sending the subscription and the metrics, all right? So we're going to actually orchestrate CUUP, and then we're going to show the registration from it. So there you go. In the beginning, there's no CUUP. We just start running it. Oh, the mic went off. And when it goes up, starts the registration, E1 setup. Let's fast forward here. How much time do I still have? Okay, I think we're almost done. 5 minutes, okay. So I will fast forward here. Then we'll try to instantiate SD-RAN. Like I said, we did this all on video because we have very short time. So we have KPI Mon. It has a subscription. We have a cell phone here. It's a Samsung, easier to set up. And as you can see here, the total NB initial is 2. It's going to increase because, or decrease depending on the connectivity. So it's 1, 5, but it's not doing anything right now. Just fast forward, let's connect. There you go. So when there's no traffic, it's 0. Then we're going to open YouTube, and the metrics are here from E2. They're all showing up here, and you can see it goes all the way up to 15. 5 is going to report the E2 metrics into the system. Okay, so basically that's the work we've been doing. So to sum it up, what we're trying to do, and for future work, we will explore 7.2x split deployment. It's something that we wish to do. Decoupling, right? We're trying to first make everything work in the cloud. So that's our main goal first. Then we'll look at the performance, because without the PDK and only socket mode, we know we will have latency and throughput issues. We're going to run into that. Also, SD-RAN and RAN orchestration in the public cloud, we're going to do that too, right? That's our main goal, okay? And that's it, okay? Thanks.